Styrofoam is the trademarked brand name originally introduced by the Dow Chemical Company to describe a particular form of extruded polystyrene foam, although in common usage the term has become synonymous with a wide range of expanded polystyrene foams. It is a lightweight plastic material composed primarily of polystyrene, a polymer made from the monomer styrene, which is derived from petroleum and natural gas products. Styrofoam's defining characteristic is its cellular structure, in which gas-filled bubbles are trapped within a solid polystyrene matrix, giving it very low density and excellent insulating properties. This structure results from either extrusion or expansion processes in which polystyrene beads are softened with heat and expanded by blowing agents, forming a rigid foam that can be shaped into a wide variety of products. The physical properties of Styrofoam are central to its utility. It is composed of approximately 95% air, which makes it extremely light while maintaining structural rigidity. This cellular composition gives the material low thermal conductivity, making it an excellent thermal insulator, and also provides good resistance to moisture and many chemical substances. Styrofoam is dimensionally stable, resists mold and mildew, and can be manufactured in a variety of thicknesses and densities depending on the intended application. However, it is relatively brittle, flammable, and prone to degradation when exposed to ultraviolet radiation and certain solvents, which limits some of its uses. Styrofoam has widespread industrial and commercial applications. One of its primary uses is in the construction sector, where extruded polystyrene foam boards are employed as insulation in walls, roofs, and foundations. Its ability to resist moisture and maintain insulating capacity over long periods makes it especially useful for preventing thermal losses in buildings and in civil engineering projects such as highways and airport runways, where it can reduce the effects of frost heave. Styrofoam sheets are also commonly used in cold storage facilities, refrigeration units, and industrial freezers. In packaging, Styrofoam is ubiquitous due to its combination of cushioning properties and lightness. Expanded polystyrene foam molded into custom shapes protects electronics, appliances, and fragile goods during shipping, while Styrofoam peanuts and blocks are used as loose-fill packaging materials. The food industry has long used Styrofoam containers, trays, and cups because of their insulating ability, which keeps hot foods hot and cold foods cold while remaining inexpensive to produce. Despite concerns about environmental impact, these applications persist due to cost-effectiveness and convenience. Scientific and laboratory uses of Styrofoam take advantage of its insulating and structural properties. In laboratories, Styrofoam containers and coolers are employed to transport biological samples, reagents, and temperature-sensitive pharmaceuticals such as vaccines. Its ability to maintain stable temperatures for extended periods has made it a reliable material in biomedical logistics. In experimental physics and engineering, Styrofoam has been used as a low-density medium for shockwave experiments, as well as a calibration material in radiation dosimetry, where its composition and density are similar to that of soft tissue. Because it is easy to shape and machine, Styrofoam has also been used in prototyping and modeling, from architectural mock-ups to aeronautical models in wind tunnel testing. Styrofoam has applications in marine and aquaculture industries as well. Due to its buoyancy, it is often used to construct flotation devices, floating docks, and fish farming equipment. In the creative and educational sectors, Styrofoam is widely used in art, crafts, and school projects since it can be cut, carved, and painted with ease. Despite its versatility, Styrofoam faces increasing criticism and regulatory restrictions due to its environmental impact. It is non-biodegradable and persists in ecosystems for centuries, fragmenting into microplastics that pollute waterways and harm marine life. Recycling of Styrofoam is technically possible but economically challenging, as its lightness makes collection and transport inefficient relative to its value. Consequently, many municipalities have moved toward banning single-use Styrofoam food containers and promoting alternative biodegradable materials. In summary, Styrofoam represents one of the most widely used polymer foams in modern industry, combining lightweight structure, thermal insulation, and versatility of application. Its significance spans from construction and packaging to biomedical science and marine industries, although its environmental drawbacks are driving research toward more sustainable alternatives.